In 1936, a 14-year-old schoolboy went on a museum trip in London to see an exhibition of Minoan archaeology. The exhibition was being shown around by the man who had excavated the palace at Knossos himself, Arthur Evans, then 85 years old and the most famous archaeologist in Britain. Evans showed the class the clay tablets he had dug up in Crete, covered in a script nobody could read. He explained that they had defeated everyone who had tried. The boy put his hand up and asked whether it was true that they were still undeciphered. Evans said yes. The boy decided on the spot that he would be the one to do it. 16 years later, he did. He was not a classicist, he was not an academic, and he was not remotely qualified. He was an architect who worked on it in the evenings. His name was Michael Ventris, and this is the strangest decipherment story of the 20th century, including the part at the end that almost nobody mentions. Start with what he was up against, because it was worse than it sounds. Evans had excavated thousands of clay tablets at Knossos from around 1900 onward. They were written in a script he called Linear B, to distinguish it from an earlier and even more impenetrable script he called Linear A. Normally, to crack an unknown script, you need one of two things: either a bilingual text, the same message written in a script you can read alongside one you cannot, which is how Egyptian hieroglyphs fell to the Rosetta Stone, or you need to know what language is underneath. If you know the language, you can work out which signs make which sounds, because you know what the words are supposed to be. Linear B offered neither. There was no bilingual. And the language was the whole problem, because nobody knew what these people had spoken. Evans himself had a firm opinion, and it turned out to be the single biggest obstacle to solving it. He was convinced that Knossos was the center of a Minoan civilization that had dominated mainland Greece, and that the language of the tablets was therefore Minoan. Some unknown pre-Greek language related to nothing, spoken by a people who had been the masters rather than the subjects of the Greek world. He was so committed to this that he was slow to publish the tablets at all, which meant that for decades most scholars could not even look at the evidence. And there was one thing everybody agreed on. Whatever Linear B was, it was definitely not Greek. Greek writing began with the alphabet, borrowed from the Phoenicians around the 8th century BCE. The Linear B tablets were 500 years older than that. Suggesting they were Greek would mean claiming that Greeks were writing half a millennium before anyone thought they had learned how. Hold on to that, because it is going to matter. Now, Ventris. He was not a classical scholar. He trained as an architect, and by the 1950s he was a working one, designing schools for the Ministry of Education. He was, however, extraordinary with languages. He had picked up Polish as a child from his mother's side, learned Swiss German at school, and taught himself classical Greek. He later learned enough Swedish in a matter of weeks to read a technical article he needed. And during the war, he served in the RAF as a navigator in an environment saturated with codes, ciphers, and systematic pattern analysis. He never worked at Bletchley Park, but the methods of the period were in the air, and his approach to Linear B looks much more like cryptography than like classics. He worked on it in his own time for years, and he did something unusual with it. Between 1951 and 1952, he wrote up his progress in a series of documents he called work notes, and he posted them out at his own expense to every scholar in the world who was working on the problem. He was not trying to win a race. He was trying to solve it, and he thought more brains helped. His method was a grid. He noticed that certain signs appeared in the same positions in otherwise similar words, in a way that looked like grammatical endings. If a word appears in one form, in one context, and a slightly different form in another, and the difference is always in the final sign, then those signs are probably related. So he built a table. Signs that seemed to share a consonant went in the same row. Signs that seemed to share a vowel went in the same column. He had no idea what any of the sounds were. He was just mapping which signs were relatives of which other signs. It was pure structure with no content at all, a skeleton of a language he could not hear. Then he needed a way in, and he found it in place names. There was an existing suggestion from an American scholar named Alice Kober and others that certain words appearing frequently on the Knossos tablets might be the names of Cretan towns, which would presumably have survived into later Greek in recognizable form. Ventris tried it. If one frequent word was Knossos and another was Amnisos, its harbour, and another was Phaistos, then that fixed a handful of specific sounds into specific cells in his grid. And once a few cells were fixed, the grid did the rest. Every sign in the same row had to share that consonant. Every sign in the same column had to share that vowel. Sounds propagated outward across the table. Words started to appear, and this is the part that I think tells you the most about him, because his own reaction was not triumph, it was resistance. The words that came out looked like Greek, archaic, strangely spelled, 500 years too early Greek, but Greek. Ventris had spent years arguing that the language was not Greek. His own working hypothesis had been that it was related to Etruscan. He had said so in print, repeatedly. In Work Note 20, sent out in June 1952, he laid out the possibility with a title that reads like a man arguing with himself, are the Knossos and Pylos tablets written in Greek. He described the Greek hypothesis as a frivolous digression that he expected to abandon. He did not abandon it. It kept working. On the 1st of July 1952, he announced it on BBC Radio. Listening to that broadcast was a Cambridge classicist named John Chadwick, who happened to be an expert in exactly the thing that was now required, early Greek dialects. He wrote to Ventris the next day. They began working together, and Chadwick supplied the philological rigor that Ventris, as a non-specialist, could not. But the decisive moment came from the other side of the world, and it was as close to a controlled experiment as this field ever gets. An American archaeologist, Carl Blegen, had been excavating at Pylos on the Greek mainland and had a batch of tablets that had not yet been published. Nobody, including Ventris, had seen them. In 1953, Blegen applied Ventris's values to one of them. The tablet listed vessels. Beside a drawing of a three-legged pot, the signs read T repode, tripodes, tripods. The tablet had drawings of the objects next to the words, and the words matched the pictures, in Greek, on material Ventris had never seen and could not have fitted his system to. Blegen wrote to him, "It all fits in with the Greek solution." That was it. The system was real. And here is what the tablets turned out to say. Not poetry, not history, not law, not a single line of literature. Inventories. Sheep, counted by the tens of thousands, broken down by location and by the shepherd responsible. Chariot wheels, including an entry recording a set as unserviceable. Bronze allocations, perfumed oil, lists of women and children assigned to workshops with their daily rations. It is an accountant's archive, kept by professional scribes, filed and updated, which is deflating, and it is also the reason we have any of it. Those tablets were unfired clay, and they were probably meant to be wiped and reused once the year's accounts were settled. Every single tablet we possess survives because the building it was stored in burned down, and the fire baked the clay hard. But the inventories carry something the scribes never intended to record. They pushed the documented history of the Greek language back 500 years in a single stroke. And scattered through the ration lists and the livestock counts are names of people and of gods that classical Greeks would still be using 1,000 years later. Poseidon is there, Athena, Dionysus. Ventris and Chadwick wrote it all up in a book called Documents in Mycenaean Greek. On the 6th of September 1956, driving home late at night on a road north of London, Michael Ventris ran into the back of a parked lorry and was killed. He was 34 years old. The book was published a few weeks later. He had cracked the script, been vindicated by an independent test, changed the accepted history of a language, and he did not live to see the work in print. He was an architect. He did it in the evenings. He gave away his working notes for free to people who could have beaten him to it, because he cared more about the answer than about being the one who found it. And it started because a 14-year-old put his hand up in a museum and asked a question. If you could hand one undeciphered script to someone like Ventris tomorrow, which one would you want cracked first?